So now, in this video, we have a 555 timer. You should be able to hear a bunch of clicking. We have a passive buzzer right here. The passive buzzer makes a click when you apply a higher voltage to it, and also makes a click when you apply a lower voltage to it. It just keeps passing current. It's a passive buzzer. The active buzzer, you just apply power to it and then it makes a tone. This is going to be loud and annoying. So I'm going to keep it as short as possible. I just connected that to the 5 rail. You do not want to keep power applied to this one. It will just keep passing current. It'll get waste heat. So that's the best case scenario. I don't even know if that will damage you or not. But you want to put a capacitor in series so that it just clicks. And that's all it's going to do anyways when you change the voltage. So doesn't matter exactly the value capacitance right there. Maybe you can go too high or too low, and you just adjust the value as needed. But in any case, 10 microfarad seems to work very well. We have the 555. So first off, it's wired in astable mode, and it's clicking. We can adjust it. I have a trim pot. I can speed it up till we got a buzz, or just a series of clicks. So be aware that this is higher resistance right there. More resistance, the longer, and then this is less resistance, the quicker that the clicks go, until they turn into buzzes. I am using a breadboard power supply. A lot of people like it. You plug the other end of this cable right here. There's an adapter which comes separately, usually. You can buy them together. But I bought a whole bunch of these, and I'm using a power supply from a pocket oscilloscope. So you plug it into the wall. It takes the 120 AC, and this one is outputting 9 volts, which is an okay voltage for this. 7 volts would be better. You got less waste power. You want to stay a couple volts above the 5 volts if you're using it. You could also move this jumper, go to 3.3 volts, or you could turn one rail off or the other. You can also use these pins. Those top on the left right there are 5 volts, the top two. The bottom two are 3.3 volts right there. That's the positive. And then we got ground. All 4 of these are ground, like connecting to the ground rail right there. Be aware of that. They are not to be connected directly together. They are to be fed to part of the circuit where you want ground or 5 volts or 3.3 volts. Just be aware of that. So we'll come back, and the breadboard, it's a regulator, which means it takes this higher voltage and in a sense it adds resistance as needed to maintain, in this case, 5 volts at the rail. So it's like a resistance. It just limits the current as needed, and therefore it just creates waste heat. It doesn't convert the higher voltage into more current coming out than is needed to come in. The current is the same right there, so it doesn't conserve power. Just be aware that if you want to use one of these breadboard power supplies, but a lot of people do, which is why I'm showing it in this video. So it's got these pins right there that just plug right into the breadboard. So that's what makes it a breadboard power supply. In the grand schemes of things, it's just a regulator. In this case, we're going to use the 5 volt regulator. So we're not going to dwell on that too long. Now, we have the 555 timer. And when you learn about the 555 timer, you learn about the 3 modes and astable, well, 3 main modes. Astable is probably the most commonly used one. It keeps the output going high and low. Often I flash LEDs. The LEDs are just showing it's high or low. Typically use output for something else where it helps to have it keep going high and low over time. Like a clock. You got a certain period of time where it's high and then low and so on. It just keeps repeating, and then other circuitry can respond to that as need be. We have 2 pins that are looking at the inputs. So starting from top left, we got 1, 2, 3, 4, and then jump across 5, 6, 7, 8. And pin 6 is the threshold pin. It's waiting until the capacitor gets to 2/3 supply voltage, and then it tells the output to go low. And then pin 2 is waiting for the capacitor to discharge to 1/3 supply voltage. When it does, it tells the output to go high. The capacitor charges while the output's high, and discharges, well, it actually discharges. The through pin 7 to ground right there when the output is low. So the capacitor is following what the input is doing. In fact, you can feedback, or the output is doing, I mean, you can feedback voltage from the output to help charge the capacitor up to 2/3, and then it goes low, helps discharge the capacitor to 1/3. But remember, the NE555 doesn't output all the way to the positive rail, so that does cause problems. You might want to use a MOSFET base 555, but we're not going to worry about that too much. They have rail-to-rail output where you get 5 volts out, 0 volts out, but they don't provide much current. Probably won't be very good for this circuit, particular one, as is. So, in any case, we'll get back to this. We got the capacitor, and so larger value capacitors will take longer to charge for a given current, and lower value capacitors will charge quicker for a given current. So I selected the values of the capacitor and the trim pot, as you can see here, and even our kind of minimum resistance, 220 ohms right there, to get this result right there. So I'll turn the power back off. That's you know, one kind of nice thing about these breadboard power supplies right there. You got a button there to turn them on and off. The green LED lights up when it's on and turns off when it's off. So we have the capacitor, 10 microfarad. Also, before I forget, pin 4 is to the positive supply. If that senses close to ground, it's like 0.5 volts or less, ground is 0 volts, go to the reset pin. It's going to hold the output low no matter what. That's what reset means. So low input to pin 4 tells the output to go low and stay low no matter what. And it'll keep discharging the capacitor no matter what. We don't want it to do anything, so we put it to the positive supply. So we get to the resistance. Again, we're counting on the charging and discharging of the capacitor. I have a trim pot right here, and the middle pin is the wiper. We have a resistive element. It goes from the top pin to the bottom pin, or vice versa, whatever. That's about 10,000 ohms of resistance. These are not highly accurate. You know, maybe it's like 10,000, 11,000, I mean. It's probably like 10% off, maybe even worse. But it doesn't matter. All that matters is that we have a resistance and then a wiper that slides across it. So when we only use 2 of them, then it's a variable resistor. When we have the arrow pointed towards this bottom one, then the resistance is full. Whatever current flows through here has to go all the way from one end to the other before it gets to the wiper. If we turn it to where it's right next to that jumper, the arrow, or that pin right there, arrow right to the pin, the wiper is right to that pin. There's hardly any resistance, and therefore current doesn't have to flow through much resistance. It's going to flow a lot more easily. So we'll pop that back in. And so now it is farther away right there, so we have more resistance. I'll turn this on. We have the slow clicks. We're going to turn it off. I go back, and then these 2 jumpers right there are almost, you know, directly connected. You know, it's not a perfect connection, not a perfect trim pot. Going to be just a speck of resistance, but hardly any right there. When I turn it on, it will buzz. Right there. This is a cheap breadboard. This is going to kind of fall out a little bit more than it would with a higher quality board, and all the connections won't be as good. Keep that in mind. And of course, we have to power the 555 timer. We got positive supply to pin 8, and then the negative supply to pin 1 up there. As you can see, we got that jumper to connect 2 and 6 together because they're both looking at the same voltage. You don't have to wire the 555 timer up that way, but for stable mode, you pretty much do. So I included on the diagram there, this is a dual inline package. There's you know, pins on both sides right there. They're a bit wider than these component pins, so you know, they make better connection with this breadboard. But in case, they're still pins. So start top left, 1 to 4, jump across 5 to 8. There's usually 1 or 2. I think this one just has that top one, but maybe there's a little divot right there. Divots go to the top. Be aware of that. And then I got the names of the pins there. We've got ground, trigger, output, and reset. We're using all 4 of those. Control pin, a lot of times you'll see a capacitor pin 5 capacitor going to ground. That just helps steady that voltage. The control pin inside the 555 timer, there is a voltage divider. So there's a 2/3 supply voltage. You think of 3 resistors, 2/3 supply voltage, and then 1/3 supply voltage between 3 equal value capacitors. Pin 5 goes directly to that 2/3 side of the voltage divider right there. So you can give it a voltage to help adjust it, you know, like with the trim pot or something. Raise where that 2/3 or lower it, whatever the case may be. And the 1/3 side will be half of whatever you set it to. So it won't be 2/3 and 1/3 of the supply voltage anymore. It'll be some other voltage as a high, and then as a low will be half of that. So hopefully that makes sense. But in any case, yeah, that's really about it. These capacitors are polarized, so are the buzzers. There is a plus up there. Now the passive buzzer, I was pretty sure, I haven't used these for a while, this was a passive buzzer because you can see the circuitry right there. So I was pretty sure if you see the circuitry, that's passive, whereas active, this one you just put to the supply rail, it buzzes, as we showed earlier, has epoxy in there. So I'll demonstrate that really quick. We got the buzzing. I'll pop this one off. We got the epoxy, and I'll put it to the supply rail right there. And it's a loud beep. I should have warned you. Sorry if that was obnoxious. But in any case, this does not have the epoxy. You should hear a click right there. And I think I can feel it warming up. I don't think that's good for it to leave it there. This one you can apply power to it as long as you want. Doesn't have to be 5 volts. I think like 3.5 volts or something. I still got a nice buzz out of it. So, you know, you can reduce like a little voltage to it. Won't be quite as loud and whatnot. If you really want to silence it, you know, put your finger over it. So yeah, power's still on. And you'll hear this is not near as obnoxious right there. So some of my videos I just hold my finger over it right there to not give you a real loud screech, which sounds terrible, especially if your TV or computer is loud. But in any case, that mostly covers it. Another thing I'll mention, as I said before, I'm using an NE 555. If it says micro A 555 or UA 555, however you want to look at it, it's probably going to work exactly the same. And then there's the LM 555 that uses MOSFET transistors at the output. So you don't get near as much current that it can provide at the output. That's going to throw the voltage off if you try to get the maximum current out of it. But as long as you're just looking at the voltage, it will go all the way basically to 5 volts, all the way to ground. Just a speck will be lost. So if you really need an output that goes rail to rail, then you'd want to use a MOSFET version like the LM555. I do have probably the LM555. I have some MOSFET ones that go rail to rail. But you would use that as a signal. You would have other circuitry looking at it. You know, maybe a different 555. The inputs will go to pin 2 and 6. As it alternates from high to low, the output is going to change, you know, the opposite. High in, low out, low in, high out. That's an inverter circuit. So, in any case, whenever you're looking at these circuits, whatever I show you is not really intended to be a great circuit where you can do, you know, a lot of interesting things with it. The main point, this is the passive one, is that you understand the basic principles involved and also modify it. We could, you know, you kind of want 220 as a minimum resistance for 5 volts. We could go higher, and then the 10 microfarad capacitor will take longer to charge. We won't be able to get the high pitch noise as, you know, as high a pitch noise if we went higher, although it does discharge just as quick. But you could go really high with that input, and then this will change it, you know, like just a little bit, especially for the charge, but not for the discharge. Something you got to keep in mind. And in any case, you got all kinds of ways to modify this. If you want higher pitch, you can use a lower value capacitor. And if you want it to go even slower, then you can use a higher value capacitor. That's kind of the simplest way to do this, but it's still adjustable. So we got adjustability there. You know, fine-tune adjustability, and then for like larger adjustability, your best option is to take the capacitor and either give it a much larger value or much lower value. So there's all kinds of things to learn from this. Not a complex circuit though, really. once you got the basics down. So that is about it. And by the way, the 555, since this accidentally got shown, came out of this kit here. So when I use a 555 timer or an LM358, it's almost always one of these 4 components. So 2 of them are 555, 2 of them are LM358. And I don't know which one is which. I usually pick it up this way. I noticed I have a loop. Actually, I moved the loop closer. So I got the loop. You can see this. That's an LM358. I'm looking through the camera. So I just know that it looks a bit different than the 555. So I can tell. But yeah, there you can see we got LM358 right there. And 555 is just as easy to read. You may need the loop though. So with the camera, I pretty much definitely need the loop. In person, I can look with my eyes, but not super easy to read. But you know, since I know what the part numbers are for components that I have, for the most part, you know, I can tell just by looking at them. But if you're using unfamiliar components or something, definitely use the loop unless your eyes are good enough where you can see the detail. And some of them are written better than others. Some are really easy to read from a distance. Other ones you gotta get close, like these right here. So that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They'll help a lot. I'll see you in the next video.